In this video, we're going to talk about the average velocity. So we've talked about the position function and in general about velocity and acceleration. But what we really want is to figure out if we have the position function, how can we come up with a formula for the velocity? So, all right, so let's talk about average velocity. Average velocity of an object from one time point, let's call it A, to another time point B later on. What that will be is the change in position from time A to time B divided by the change in times. So just sort of in words, the average velocity is going to be your change in position divided by your change in time. So for instance, say you told somebody, well, I drove 120 miles down the interstate and it took me 2 hours, right, to drive 120 miles. So your change in position would be 120, and then your change in time would be 2 hours. So 120 divided by 2 would be 60. So your average velocity would be 60 miles per hour in that case. Okay, so this is a measure of velocity that people use pretty much every day. When you're talking about, trips or things like that. So it's a pretty common measure of velocity. If I have a position function, right, for some object in motion, then the average velocity of the object from time A to time B has this form right here. So how does that work? Well, remember f is the position function. So f of b, right, whatever the number you have for b, if you plug that into f, that's going to give you the position on the number line at time B, right? And then f of a, that will be the position on the number line at time A, right? So say f of b was 5 and f of a was 3, then you subtract those two. 5 minus 3 would be 2. So your position changed by 2 units. Okay, and then down here on the bottom, right, b minus a, those are the time values that you had. So say B was 10 and A was 5, right? That's from 5 seconds to 10 seconds. You would subtract those two. 10 minus 5, right, is equal to 5. So the bottom expression there is just the change in time. So this is just this formula, right, when we have a position function. Change in position over a change in time. All right, let's take a look at an example. If f of t equals sine of pi t is the position function for an object, find the average velocity from time 0 to time 10. Okay, so we have the position function. We're going to use this formula for the average velocity. And the first time period is 0, so that will be a. And then the later time period is 10, right? And so we would plug 0 in for a and b, 10 in for b, right? And that's what we would get. Then f of 10, right, is what we would get when we plug in 10 to our position function. So we get 10 pi here, and plug in 0. We get sine of 0 pi, which is sine 0. Both of those values on top are 0, right? 0 minus 0. So I wind up with 0 over 10, which is just equal to 0. So if we were measuring the position in feet and the time in seconds, right, the average velocity here would be 0 feet per second. So already you probably see some of the downside to using average velocity right here. The average velocity was 0, right? And the reason why that really happened was because it was at the same position at time 10 as it was in time 0. So I got the same number here, which just happened to be 0 in the number line, and then I subtracted that out, and I get 0. So if you have a position function and the object is moving around and you take the average velocity and it returns to its starting position basically, then you're always going to get an average velocity of 0. If you take a look though at the motion here I have that position function, right, and here's the green particle right here, and here I'm using b for that variable instead of a, because we'll talk about the velocity later on. So you can see as I let the time run from 0 to 10, right? That this particle is in fact moving around quite a bit, right? So the average velocity really doesn't tell us much at all, right, about what happened in between 0 and 10, right? And it happened because it started here, the particle started here at 0 at time 0 and then moved around a bunch, and then at time 10 it was back where it started at time 0. Anytime that happens, right, we're going to have an average velocity of 0. And so therefore the average velocity just didn't really do a good job at all of describing the motion here. All right, let's take a look at another example. In this case, we are going to have f of t equals sine of 10 pi t, right? So, and we want to calculate the average velocity from time 0 to time 10. So this problem is going to look an awful lot like the previous problem, right? We have the position function, so we're going to use this formula for the average velocity. It was from time 0 to time 10, so a will be 0, b is 10. And then we'll plug those in to the position function. And so when I plug in a 10, I get sine of 100 pi. And then when I plug in the 0, I get sine of 0 pi. Again, both of those are 0, right? And so on top, I'm going to get 0 over 10, which is just equal to 0. So again, I get that same value there. All right, so average velocity is not really good at describing some important aspects of motion. And just to kind of see how bad it is, let's take a look at the last two examples together on Desmos. So here I have the other position function. Oops, don't want to turn that one on, but this one right here. So now I'll have an orange point and a green point, and remember they both had the same average velocity over the interval from 0 to 10, right? But watch what happens here. You can see that the motion is a lot different. If I slow it down a little bit, you can actually see the orange particle. The orange particle is moving much more quickly, right, than the green particle is over that time period. Okay, but again, they both had the same average velocity over that time period. So that's really bad. It doesn't give us any indication of what the motion was like at all. These particles, yes, they are both moving back and forth from -1 to 1, right? But in terms of how fast are the particles going, the average velocity really doesn't tell us that the orange particle is going way more quickly, right, than the green particle here. So the average velocity, again, is just not great for describing the motion. It's just not good enough for what we really need here. So the question is then, okay, well, if average velocity is so bad, then why are we even looking at it? Why are we bothering with this at all, right? And the answer is that, well, the average velocity is kind of a starting point to get the velocity function, which is what we need. So even though it's not great, right, at telling us what's going on over some period of time with the motion in terms of how fast exactly at any time the particle is moving, right, we can use it as a starting point to get that information. And in the next video, that's what we're going to talk about. How do we use the average velocity formula to get the velocity at any point in time, not just from one time period to another.